Okay, now if y is 1 by x plus b, then you have to get the nth derivative. You got here y1 equal to x to the power n derivative is n x to the power n minus 1. By using that y1, you are getting here minus 1 into this you are getting. Now, if you differentiate this with respect to x, you are going to get y2. Y2 is equal to the same format. You see, minus 1 is a constant. You can write here minus 1. And then a is a constant. Here you are writing a. And then if you differentiate ax plus b to the power minus, because this is containing only the term containing x is there, that you have to differentiate because you are differentiating with respect to x. Okay, now x to the power n means just like here, if you take the formula x to the power n, you will get here n x to the power n minus 1, and the inner derivative you are going to get as it is, like the previous one. Here a into a you are getting here, that is a square. Directly here you are writing a square, and the same you are writing here. You take minus 1 as common from the previous one, and here also you take minus 1 as common, you get minus 1 whole square. Okay, into what is the remaining here? Minus 1 minus 1, if you take outside, the remaining is 1 into 2 is there. Okay, 1 into 2, the remaining thing you are writing as it is. Okay, now after that, again you differentiate that with respect to x. If you differentiate y2, you see here minus 1 square is a constant. Minus 1 square is a constant. Minus 1 square is a constant. And then here you see, here 1 is there, 2 is there. 1, then 2 is there. 1 is there, 2 is there, and again the same format. You see, this is a, here to here is a constant is there. Minus 1 square and 1 into 2 is a constant, and then here you got a square is also just like a constant. Here a cube is there, but here you consider a square as it is. But this is the term containing x is x plus b to the power minus 3. That you have to differentiate because that containing x is there. If you differentiate again, you get here x to the power n means n x to the power n minus 1. By using that format, you are adding this, and then again inner derivative here a square is there. If you take the inner derivative a square into a, you are getting this a cube. Here you are adding a cube. Okay, now again you take here minus 1, you take it as common from each bracket. Here you get minus 1 cube, 1 into 2 into 3 into x plus b to the power minus 4 into a cube. Okay, now you got y1 here, this is y1, and this is y2, and this is y3. Now just like here you see, y3 is there. Wherever that 3 is there, that you are replaced by minus 1, that you have replaced by n, so that you get the nth one. Here y3 is there, you are writing yn. Just like here y2 is there, you are writing minus 1 square. Here you have to write what? Yn means minus 1 to the power n. And then you see here, y2 means you are getting 1 into 2 is there. And y3 means 1 into 2 into 3 is there. You see yn means 1, 2, 3, so on to n you will get. Is it not? Just like 1, 3 means you are getting 1 into 2 into 3. N means you will get 1 into 2 into 3 into so on to n you are getting. And then here you see, here y2 means you are getting ax plus b to the power minus 3 you are getting. That means for two terms you have to add plus 1, so that you are getting here y3 means you are getting here minus 4. Similarly here you get minus n plus 1, and then here into, you see y3 is there here. Here you are getting a cube. Here y2 is there, you are getting a square. That means yn means how much you will get? A to the power n. Now here to here you see already you know n factorial minus 1 to the power n you write as it is. But here 1 into 2 into 3 so on to n. Now if you start with n into n minus 1, n minus 2, so on to 3 into 2 into 1 you are getting. That is called n factorial. The same you are writing here. Here you see, you observe this term here to here. Here y 1 into 2 into 3 so on to n is there, that you are writing as n factorial. And then here you see a to the power n is there, that you are writing as it is, a to the power n. And here you see x plus b to the power minus n plus, already you know a to the power minus m you can write as 1 by a to the power m. The same you are applying and you are writing here, and then you are writing here. Okay, now totally what you got, yn equal to, if y is 1 by x plus b, yn equal to, you got here this much you are getting. The same here you are writing nth derivative of 1 by x plus b is equal to, the same you are writing here. This is the nth derivative of 1 by x plus b. The same you got here in the previous case by taking ax plus b to the power m, where m equal to minus 1. You got the same, you see here, you got here the same by taking that. You see, you got the same here. Case number 4, by taking that y is equal to x plus b to the power m, y equal to x plus b to the power m, you got here case number 4. The same you are getting here, but here you put by taking y1, y2, then y3. Okay, now we will go for the next one. Okay, now the next one is y is equal to log ax plus b. Already you know, if y is this, then you have to find out the nth derivative. Here also the same process you are doing here. First you are getting y1, then y2, then y3 you are getting. Okay, first here y1 is there. Y1 means if you differentiate y, you will get y1. Now log x is 1 by x, and then the inner derivative is what? The inner derivative is d by dx of ax plus b, d by dx of ax plus b, so that you will get here the inner derivative is a you are getting. Now what you got here, 1 by x plus b, you can write as x plus b to the power minus 1. Same, just like 1 by a to the power m, you are writing a to the power minus m into a, into you are getting. Okay, now y2 is equal to y2 equal to, again in the same way, x to power n format, derivative is n x to power n minus 1, n minus 1, the same you are writing here. And already one a is there. Again, if you differentiate this, you will get the inner derivative a. That means you are writing here minus 1 into 1 ax plus b to the power minus 2 into a square you are writing. Similarly, again you differentiate this with respect to x, so that you get y3. Y3 means here, here you see minus 1 is a constant, 1 is a constant, and a square is also a constant. Here what is the term containing that x is, the component containing x is ax plus b to the power minus 2. If you differentiate that with respect to x, how much you get? Again the same derivative, the nth derivative is nx to the power n minus 1. Nx to the power n minus 1 we have to use, so that here you are getting minus, here you are getting minus 2
Sir,
into ax plus b to the power minus 2 into x
sir,
plus b. What happened?
doubt, sir.
You asked at the last.
Okay.
Minus 1 minus 1 into 1 into here minus 20 x plus b to the power minus 3 you are getting here, and a into a square. If you here also minus 2 is there, you take minus 1 as common here, another minus 1 is already there. Minus 1 square into 1 into 2 x plus b to the power minus 3 into a cube you are getting. Okay, now the same you are writing here, minus 1 to the power n minus 1, minus 1 to the power n minus 1 into 1 into 2 into 3 so on to n minus 1 you are writing, because you see y3 means you are writing here two terms you are writing. Here yn means you have to run up to n minus 1, 1 into 2 into so on to n minus 1, and here minus 1 to the power 2 is there. Y3 means you got here 2. Here you got n minus 1. Okay, one time you have to reduce. Yn means you get here n minus 1. And here x plus b to the power, you see you got here y3 means to the power minus 3 you got. Y2 means you got minus 2 is there. And here n is there, you get here minus n. And into a to the power n. Into a to the power n you are getting. Now, minus 1 to the power n minus 1, this is you are writing as it is. Already the same factor, n factor means how you are writing, n into n minus 1, n minus 2, so on to 3 to 1 you are writing. If you take in the reverse order here, n minus 1 into n minus 2 into, you get here 2 into 1, that is you are writing as n minus 1 factorial. And then here, again the same way, a to the power minus m you can write as 1 by a to the power m, that's why you are writing here x plus b to the power n in the denominator into a to the power m. Now you got this, the general one, that the nth derivative you are getting here, the nth derivative here you are writing. Now already you know, if log x is in requirement means just to put a is equal to 1, b is equal to 0, you will get the log x derivative. And similarly, if you put n is equal, why this is calling a general means, you see, if you put n is equal to 1, you will get the first derivative. If you put n is equal to 2, you get the second derivative. That is generalizing. Okay, y1 means you get only 1, 2, 3. That is extending to n terms you are writing here. Okay, if you got the nth one, you can just by substituting n is equal to 1, 2, 3, so on, you get the different derivatives. Now the next one is y is equal to sin ax plus b. Y is equal to sin x plus b. If y is equal to sin ax plus b, then you have to find out the nth derivative. That is yn you have to find out. First you have to differentiate y with respect to x. This is also same process. First you have to get y1, then y2, then y3. Then you have to generalize and you have to write the value of yn you have to write. Here y1 is there. You see already know derivative of sin x is cos x. The same you are writing here. The inner derivative with respect to x means you will get here only a you will get here. That's why you are writing the same. Now to generalize, this is we have to rewrite this expression as sin pi by 2 plus theta equal to cos theta. That's why this is you are writing the cos ax plus b. This is you are writing. This is cos ax plus b. You are writing as sin ax plus b plus pi by 2. And then again you have to, after you rewriting that y1 in terms of sign, you write here y2 is equal to, again you differentiate y1 here. After rewriting only you have to do this. Okay, because you have to generalize. If you got here if you put cos as it is not possible to generalize. That's why you are writing in terms of sign and you are writing this. Now differentiate y1. If you differentiate y1, you get y2. And here also a is a constant, you are writing a as it is. and sine, if you differentiate, you will get here cos, whatever may be that angle it may be. Okay, the same you are writing the angle. The inner derivative with respect to x means pi by 2 is a constant. If you differentiate, you will get 0. And ax is there. If you differentiate, you will get here a into 1, that is a you will get here. Okay, and then here plus b means plus 0 you will get. That means the inner derivative is a here, and here already one a is there. Here a into cos pi by 2 plus ax plus b into a you are getting. Here this a into this a will get here a square into sine of, again this is how to rewrite. Okay, in the previous case here rewritten and you are writing. Okay, now cos pi by 2 plus ax plus b, that you are writing as sin pi by 2 plus theta equal to cos theta. Just like that, here also you are writing sin pi by 2 plus pi by 2 plus ax plus b you are writing. Okay, now a square is a square into sin. This pi by 2 plus pi by 2 you are writing as 2 pi by 2 plus x plus b. In the previous case you are writing only pi by 2 plus x plus b. Okay, of course only one term you are writing here. 1 into this you can add 1 into pi by 2. Here you can add 2 into pi by 2 plus x plus b. Now again you differentiate this with respect to x. So that you'll get here a square is a constant you are writing as it is. Sine will become cos. By differentiation, sine will become cosine, because differentiation of sin x is cos x. And the angle is same you are writing. And the inner derivative is again here you see 2 into pi by 2 is a constant. Or you can write pi, that is a constant, that is equal to 0. Ax, if you differentiate, you will get here 1, a into 1, that is a. B means will get 0. That means here 0 plus a plus 0 you are getting, that is a you are getting here. Okay, now a square into a is a cube, that you are writing. Again you are rewriting that as a cube into sine pi by 2 plus 2 pi by 2 plus x plus b. And here the same you are writing y3 equal to a cube plus sine 3 pi by 2 plus x plus b you are writing. This is you are writing as 3 into pi by 2 you are adding. Okay, now here you see you have to write the general one. You see y3 means you are adding here a cube, y2 means here you are adding a square, y1 means you are adding a into 1 is, it is not there but it is understood, a into 1 is there. That means here you can write yn equal to a to the power n, and here also you see sine 3 pi by 2 is there, this 3 into pi by 2 is there, and you see yes y2 means 2 into pi by 2 you are adding, and here you are writing y1 means you are adding 1 into pi by 2 you are adding. The same here yn is there, you are adding here sin n pi by 2 plus the same what you got here ax plus b is same for all the cases, you are adding ax plus b, ax plus b. Now this is the nth derivative. If y is equal to sin ax plus b, the nth derivative is given by yn equal to a to the power n into sin n pi by 2 plus ax plus b. Okay, the similar format here you see you got for y is equal to a cos x plus b. This is also you are doing in the same way. First what you have to do, you have to find out y1, y2, then y3, then you have to generalize. Okay, now first one here you see d by dx of cos x, that is definition of cos x is minus sin x. D by dx of cos x is sin x, and the inner derivative just like in the previous case, here also you get here a, because a into with respect to x means you get here 1, a into 1 plus 0, that is you are getting here a. And again this is you are by using this cos pi by 2 plus theta equal to minus sin theta. This minus sin, of course theta equal to here you can take x plus b here, and if you do according to this you will get here cos pi by 2 plus x plus b into e. Now the same you are writing here, here cos pi by 2 plus x plus b into e. Okay, now again you differentiate this, you will get here y2, and you remember here this you have to don't differentiate directly here. Okay, that is y1 equal to minus sign, you have to rewrite this sign in terms of cosine, then you have to differentiate, that you keep it in mind. Okay, because you have to generalize, that's why you're writing here. Okay, now y2 equal to minus sine pi by 2, that is you are differentiating cos means you get here minus sine of that angle you will get there, and our 1a is already there, and again in the inner derivative is pi by 2, if you differentiate you get 0, plus here a into 1 plus 0 you are getting, this is a you are getting here, a into a is a square, and this is you are writing as cos pi by 2 plus theta, just like that you are writing here. Okay, now what you got here finally, that is y2 you are getting here cos this pi by 2 plus pi by 2 is 2 pi by 2 plus ax plus b into here we are writing a square. Okay, now y3, this is also in the same way. You see if you a square is a constant, you cannot here you see this a square as it is, cosine will become sine, because if you differentiate cos theta you get here minus sine theta, and then here the inner derivative again you get here a square into a is a cube, you are writing here a cube, and this is the rewriting, you have to rewrite this and you have to write it cos of pi by 2 plus 2 pi by 2 plus x plus b. Okay, the same you are writing here. Okay, now this you are writing as 3 into pi by 2. Okay, this now plus x plus b into a cube you are writing. Now you have to generalize. You see here y3 is there, here you got a cube is there. Okay, here y3 is there, First one is you see here y3 is there here a cube, and here you see y2 is the a square you are adding. Yn means you can write here the right hand side here to the power a to the power n you have to write. Now here y3 equal to first you see cosine of 3 pi by 2 you are written plus of that angle. Here y2 equal to you are writing here cos 2 pi by 2 because yn means how much you get cos of n pi by 2 you are getting here. The same you are written here cos of n pi by 2 plus that angle into a to the 4 n. This is the nth derivative of cos ax plus b. Okay. Now the next one y is equal to e to the power x e to the power ax into sin bx plus c. Y is equal to e to the power x equal to sin bx plus c. Then you have to find the nth derivative. Now this is also the same pattern. Here y1 equal to first here you see product of two terms are there. You see e to the power ax is one function of x and sin bx plus c is also function of x. Two product of two functions is there. Therefore, you have to apply the derivative of two functions you have to take. Y1 because you are differentiating y with respect to x. Now, y1 equal to, you see here d by dx of u means how you are writing d by dx of u equal to u into dv by dx plus v into du by dx you are writing. You see here u equal to e to the power x that you are writing as it is. Now, if you differentiate, sine will become cosine and the inner derivative is here you are getting b. Okay, b into 1 plus 0 you are getting here that is equal to b cos bx plus v plus again here you have to write v is sin bx plus c into this is you have to differentiate e to the power x a e to the power x you are getting. Now here from these two components you can take e to the power x as common and you are writing that expression the remaining expression you have to write. Okay, now after you are writing this, don't go for y2 directly. Here first we have to do some substitution is there. Here you see a is equal to r cos theta, b is equal to r sin theta is the substitution. You have to go for that. Okay, because you have to generalize. Okay, now if you square these two terms and if you add, you will get here b square plus a square equal to r square into sin square theta plus cos square theta. Already you know this is equal to 1. 1 into r square is r square equal to, you will get b square plus a square. Now r equal to square root of a square plus b square. Okay, now here b by a divide one with the other. Here b by a means this divide with this. B by a equal to tan theta. Theta equal to, you get here tan inverse of b by a because r get cancels here. You get tan inverse of b by a. Now y1 equal to how much you are getting here? You see y1 equal to already you are taking the substitution equal to r cos theta, b equal to r sin theta. You write here e to the power ax as it is. And here you replace the values of b and a. Okay, if you replace b by r sin theta, a by r cos theta, you will get this. Now you see this expression here, you can take r as common. There are two components are there. If you multiply here, you get two components. Here r you can take it as common, and you are writing e to the power ax is already there. You are taking r into e to the power ax into. Now the remaining you see here sin theta into cos bx plus c plus cos theta into sin bx plus c you will get here by taking r as common. Now already you know sin a plus b equal to the formula, the compound angle formula. Here you can write sin a plus b equal to sin a into cos b plus cos a into sin b. By using that one here you can write theta plus bx plus c within the sine function you have to write. Okay, sine of theta plus bx plus c you are getting. Now this is what you got here, y1 equal to r into e to the power x plus into sin theta plus bx plus c you are getting. Now again you have to differentiate this with respect to here, you have to differentiate with respect to x. Now this is you have to differentiate. This is you have to differentiate this with respect to x. Now here you see y2 equal to you are getting, you keep r as it is. Okay, you keep r as it is, and here you see again you got e to the power x is one term and sine of theta plus bx plus c is another term. Again you are getting the product of two functions is there. Now again you apply the same product rule and you apply and you differentiate, you will get here first e to the power x ax as it is. If you differentiate sine, you will get here b cos theta plus whatever maybe the angle you got, the same you are writing here, and the inner derivative will become again, but the inner derivative will get here b you are getting because theta is a constant. You will get here 0. B into differentiation of x with respect to x is 1. 0 plus b into 1 plus 0 you are getting. That's why here you are getting b you are writing. Now plus b into you have to write already sine of this you are writing as it is, and if you differentiate e to the power ax you get a e to the power ax. Now here e to the power ax you can take it as common and you can write, and again here don't directly differentiate here, we don't go for a y3, don't go for directly. Now y2 equal to, here you can take e to the power x as common and you are writing. Now again you go for a substitution. What is that? A is equal to r cos theta, b equal to r sin theta. Now here also you get the same format, sin a plus b formula we are getting here, and you are writing this here. R into r is r square, e to the power ax into, you will get this. Now y3 equal to, you see y2 means you are getting r square, you are getting y3 means you will get r cube, e to the power x ax as it is, sine of 2 theta, because y2 is the written 2 theta plus that angle you are getting here, 3 theta plus that angle. Similarly y4 means r to the power 4 e to the power ax sine 4 theta plus bx plus c you are getting. Now if you replace 4 by n, yn equal to r to the power n e to the power ax into sine n theta plus bx plus, because you see y4 means r to the power 4, yn means you get here r to the power n, e to the power x as it is sine, here you got y4 means 4 theta you got, y3 means 3 theta you got, yn means you get n theta. Okay, now of course r equal to here a square plus b square to the power of half, and theta equal to tan inverse of b by a, the same you are adding here. This is the nth derivative of e to the power ax into sin bx plus c. Okay, now you take the next one. Here also this is there, here also this follows the previous one. Y is equal to e to the power ax into cos bx plus c, then you have to get the nth derivatives. Here also the same format, but the compound angle format differs here. Y1 equal to e to the power ax, we are differentiating this. First e to the power ax into, if you differentiate this, we get minus b sin bx plus c. And here first, here our product of two functions you are applying, cos bx plus c into how much you are getting, e to the power ax, if you differentiate, you will get this. Now here from these two components, you can take e to the power ax as common and you are writing. Again the same substitution is there. A is equal to r cos theta, b equal to, here don't differentiate directly here y1. Don't differentiate y1 directly. Well, first you substitute the values. A is equal to r cos theta, b is equal to r sin theta. That is the substitution. Okay. Now, so that a square plus b square are the same here, it follows as it is in the previous case, and divide one with the other, we get theta equal to tan inverse of b by a, because if you differentiate this with b by a means this by r getting cancelled here, tan theta, and you are getting the same. Now y1 equal to how much you got, the substitution is a equal to r cos theta, b equal to r sin theta. Now we are getting this formula. Okay, now here you can take r as common and you can add r e to the power x into cos theta plus bx. Why you are writing this, you see the previous one is sin a plus b formula is there, but here you got cos a minus b formula. Of course theta equal to, here you can write a minus b is there, here you can take a is equal to theta, b is equal to bx plus c. Okay, and you can apply the same, cos a minus b equal to cos a into cos b minus sin a into sin b. With the previous one, what we are taking, the previous case sin a plus b are taken, but here you get cos a minus b compound angle formula, you will get there. Okay, now here you see y1. Now you go for the differentiation of y1. y2 equal to r, you write r is a constant, you can write outside, and here again the product of two functions is there, you apply the product formula and you write e to the power x into differentiation of this, and then the inner derivative you have to write minus b, you will get, and plus cos in of that angle into e to the power ax, if you differentiate you get a e to the power ax, and again you take e to the power ax as common from these two components and you write r e to the power ax into so and so, you get, again you substitute a equal to r cos theta, b equal to r sin theta, you get here y2 is equal to, again you have to apply the same formula cos a minus b, and you can rewrite the equation so that you get r square into e to the power x into cos 2 theta plus bx plus c. Now yn you have to write, you can write, if you want y3, also you can write y3 will become what, y3 equal to r cube e to the power x into cos 3 theta plus bx plus c. If you write yn, you get r to the power n, because y2 means r square you are adding, yn means you can write r to the power n, y1 means r to the power 1 you are adding. Okay, e to the power x as it is, cos here n will become, here 2 theta is there, here n is there, you are adding n theta plus bx plus c. Now this is the nth derivative. Now here you see there are two properties are there, linearity property is there, nth derivative of f of x plus or minus g of x equal to d to the power n f of x plus or minus d to the power n g of x. So this is the linearity property, and here d to the power n k f of x equal to k into d to the power n f of x, where k being a constant. If k is a constant means you cannot k outside, and you can take the nth derivative of the remaining thing that contains x. Okay, now I will go for one problem. I will go for one problem. If y is equal to sin h square 5x, find yn. If y is equal to h square 5x, find yn. Now first you write y is equal to, you write sin h 5x. So already you know h means hyperbolic function. You are taking trigonometric hyperbolic function. Okay. Now already you know sin hyperbolic theta means you are writing e to the power theta minus e to the minus theta by 2. Wherever the theta is there, that you replace by 5x, because you don't to have the formula directly for sine hyperbolic x that you are writing in terms of exponential function. Then you are applying the nth derivative of e to the power mx or e to the power ax you are applying. Okay. Now here first you write sine hyperbolic theta equal to this format. Replace theta by 5x and you are writing this, and you have apply a minus b whole square formula, and denominator is 1 by 4 you will get here. And if you apply a minus b whole square formula, you will get this. And already you know a to the power m to the power n, you can write a to the power mn. By using that here you can write, and then here you have to use a to the power m into a to the power n is a to the power m plus n. Okay. Now by applying these two facts, that a to the power m to the power n equal to a to the power mn, a to the power m into a to the power n equal to a to the power m plus n, you are writing this. Now this is what you got, y is equal to. Okay, now you have to apply, because here you see we are not applying here directly because we don't have the direct formula that we are converting into exponential. Then you are applying the nth derivative. Okay, now yn equal to, you write here d to the power n of this. 1 by 4 is a constant you are writing, then nth derivative of this and nth derivative of e to the power, and then here you are writing 2. What is 2? 2 is a constant. Okay, the first derivative itself is, you get 0. There is no question of remaining thing. They will get, the remaining will get vanishes. Okay, one first derivative itself 0 means remaining will also get vanishes. And you are adding d to the power e to the d to the power e to the power a. The first one what are taken in the starting, the nth derivative of e to the power ax is you are getting, a to the power n into e to the power ax you are getting. And differentiation of constant, first already I am told to you, first derivative itself is 0 means the remaining will become zeros or vanishes. Okay. Now e to the power x is 10 to the power n, e to the power 10 to the power n, e to the power ax you are writing, and same you are adding here. Already you know minus 10 you can write as minus 1 into 10 you can write, minus 1 to the power n to 10 to the power n you can write, and this is follows as it is. Okay. Now 10 to the power n you can take it as common, and you can write this is the required value. Okay. Now we will see the remaining thing in the next class. And you remember here, you are not here directly applying. You are converting this into the exponential function. Then you are applying, because you know the formula for the exponential function of e to the power mx like looks like format, but we don't know directly the sine hyperbolic 5x. That's why you are writing this is in terms of exponential. Then you are applying the formula. It is not possible to write directly. Okay. Thank you.